Well, a warm welcome to everyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook. Grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today, we're working in the kitchen or maybe the pantry. We have a problem that involves a little recipe here. Equal parts height, equal parts width, and a dash of pi. Go ahead and give the problem a read for yourself. And I also want to mention that a gallon, in case you didn't know, 1 gallon, a US gallon, is approximately 3.785. We can use this number. I think there's some more decimal digits there, but it's approximately 3.785 liters, which if you're not hip with your conversions, I think you should be, but if you're not hip with your conversions, we'll call it 3,785 cubic centimeters. I think it's 0.41. Don't quote me on that, but if you'd like, you can look up the conversion from a gallon to cubic centimeters if you want. But other than that, give this problem a read. Try it out for yourself. It should only take about 3 or 4 minutes. It's not a very long problem. But this is testing your ability to represent volumes and certain equations which have maybe more than one variable and reduce them to a single variable and then work with the algebra required. So you can pause the video. Like I said, give yourself a chance to try this out for yourself first. Then when you're ready, you can come back and see how we did it here. Okay, let's get started. So a cylindrical can of tomatoes holds a gallon. That's a lot of tomatoes. So this would maybe be like in a large scale kitchen somewhere, maybe in the kitchen of like a market, I don't know, Whole Foods, Ralph's, something like that. Maybe even Costco. And the depth of the can is equal to its height. I'm not sure if that's written properly. I should probably change that. I think we're going to call its width equal to its height. Depth and height kind of mean the same thing. Let's say its width is equal to its height. What are the dimensions of the can? Now, why would we even care about this? Well, maybe you want to figure out, based on the size of your shelves, whether or not the can fit on the shelf, right? So if you're ordering a bunch of cans of tomatoes, big cans of tomatoes, you want to make sure that you can actually fit this on your shelf. So if you call the manufacturer, or if you call the tomato production company, distribution company, and you ask them, hey, what size cans do you have? And maybe a guy is just looking over in the inventory and says, oh, we have gallon cans, and the height's the same as the width. And then maybe the phone line gets cut off. It's a mystery. Well, how tall is the can in that case? These are practical applications, just a suggestion for what this could be. It could be a cylindrical bucket of lemons. It could be anything really, but just trying to make it fun here. So we need to represent this. Let's draw a quick little sketch of a cylinder, and its width needs to be the same as the height. So something maybe like that. Shouldn't be curved at the end there. Let's try to make that straight. That looks pretty good. And here we have, of course, the radius, whereas across the entire distance here, this would be the diameter. And what we're saying here is that this is, let's call it h, and this distance is also h. They are the same length. Right, so you need to recall the formula for the volume of a can, rather a volume of a cylinder, and that is simply base area, pi r squared, times the height. So what we're going to do is we're going to convert this equation into a single variable. And in order to do that, you have to realize that the width, this is really like the diameter, and the diameter, of course, is double the length of the radius. So we can call that 2r, which means that our radius here is equal to the height over 2. Okay, now we're getting somewhere. We're able to use this and substitute it into the volume formula. Here we go. V equals pi times h over 2 squared times h again, which means we're going to have pi times h squared over 4 times h. Let's clean that up a little bit. Let's call it pi over 4 h cubed. This is the expression for the volume. And we know that it's equal to 1 gallon. But since a gallon is not a unit of distance at all, it's not a cubic unit of distance, I should say. Like centimeters cubed is obviously a cubic representation of centimeters. A gallon doesn't really have that, so we need to use this conversion factor, where pi over 4 h cubed is equals to, let's call it 3,785. I'm not going to use the decimal 0.41. You could if you'd like. You make it more precise that way, but we're just going to keep it simple here. And now you can solve for the height. We're going to multiply both sides by 4, which I guess you can do with a calculator. You're going to need a calculator at some point anyways. I definitely don't expect you to be taking cube roots of nasty decimal numbers. If you were to do that, what would you get? I think you would get 15,600 over pi. And of course, to find the height, we would have to take the cube root of that. And this is going to be, let's see, approximately, let's get a good approximation for it. Do this on my calculator. Approximately 17.06, and this is going to be in centimeters. So the height is going to be 17.06 centimeters, and the radius, since it's the height over 2, is going to be this divided by 2, or approximately 8.53 centimeters. Those are the dimensions of the can. So if we need to figure out whether or not we can fit this in the shelf needs to have 17.06 centimeters of space. Or if it's a really big shelf, maybe you can stack multiple cans on top of each other. Okay, and that's our answer. This problem was designed for students stepping into AP Calculus soon, where you need to be able to represent expressions that are originally in terms of one or maybe more than one variable, and then convert that into an expression in terms of just one variable. And this is a core skill that you need to know in calculus. It's not a calculus skill itself, but it's something that's required to solve more intense calculus problems. All right, I think that's enough blab out of me. I'll see you guys next time.